Morning, everybody. So, we all know why the world needs replacing gray hydrogen by green hydrogen. The manufacture of gray hydrogen represents approximately 2% of the worldwide greenhouse gases emissions. And replacing gray hydrogen by green hydrogen will not happen at large scale if we don't bring the cost down, cost of production of green hydrogen. And building and operating an electrolyzer at small scale is not difficult to achieve. And I speak about capacities of less than 1 megawatt. However, building and operating an electrolyzer at large scale and an electrolyzer which is industrially robust is more difficult to achieve. So the path for a cost decrease of green hydrogen production goes through both industrial scale production and innovation. And speaking about large scale production, you see here what is an architect view of McPhy Gigafactory. I almost could have replaced this picture, this drawing, by a real picture, since McPhy is receiving this very week its Gigafactory close to Belfort in the east of France. And it will be a 22,000 square meter facility where we will produce both some stacks and electrolyzers. So we receive it this week, it becomes true, and it's our path to large-scale industrialization. Oops. So what McPhy is about, very quickly, McPhy is currently two activities, electrolyzers and refueling stations. We are divesting one currently. It has been announced in mid-December, and with a new press release yesterday, on Monday, selling our refueling station activity to Attaway. So we will dedicate to our electrolyzer activity. We have a technology center south of Berlin, in Wildau. Approximately 300 people working in McPhy and 50% being engineers and PhDs. So McPhy is a company with a strong technological focus and whose technology has been chosen last year by an Indian EPC company, Larsen & Toubro, for manufacturing and selling electrolyzers in Indian area and Gulf countries also. And I told you, starting this week, we have our new Gigafactory, so bringing our electrolyzer production capacity, increasing it by 1 gigawatt. Why do we call it Gigafactory and why is it 1 gigawatt? Because our production capability will be 1 gigawatt per year, both for the stacks of 4 megawatt and for the electrolyzer processing unit of 16 megawatt. Very quickly on this slide, you all know, but I prefer to remind it to the others that an electrolyzer is more than a stack. The stack is at the heart of the electrolyzer, but you need also a transformer and rectifier unit. You need an electrolyzer processing unit, which is in the bottom, and then a purifying and drying unit before getting hydrogen. And at the very beginning, obviously, you need a demineralization water unit for the water and feeding the electrolyzer with water in sodium hydroxide, which is the media used by alkaline technology that is used by McPhy. So, in this frame, McPhy is mostly making stacks and electrolyzer processing units. We have chosen to build them by the powers of two. So for the electrolyzer processing unit, we started by a 1 megawatt EPU, then a 2 megawatt, then a 4 megawatt, and now we are building a 16 megawatt EPU which will be produced in our new gigafactory. It's quite large, obviously. You see it. It will be 10 meters long, 5 meters wide, and 7 meter high. And for the stacks, we started by 0.5 megawatt. We went to 1 megawatt, and now we are designing a 4 megawatt stack that will be combined with the 16 megawatt EPU, so 4 times 4 megawatt stacks, connected to the EPU of 16 megawatt, and that will be our next building block for all industrial applications that we will target. Just one word to remind you that in terms of stacks and EPUs, one size doesn't fit all. There are applications on which currently, it's more on the right side of this slide, applications that are fed by electricity from the grid, and therefore, as the electricity price is rather expensive, the OPEX are very important, so the energy efficiency is very important. Whereas in the future, we see the market going more to the left of the slide, meaning renewable energy schemes feeding, large parks of electrolyzers, and there the capex will be more important. It's quite difficult for OEMs like us to match both OPEX and CAPEX. So we think that one size doesn't fit all, and today we are more building the first one, to fit with the needs of low OPEX. And in terms of cost, because that was the purpose of my speech, a 1 megawatt stack plus a 1 megawatt processing unit and a transformer rectifier in a container, the market price, we have seen many of them for small mobility applications, were around 1.7 to 2 million per megawatt. When we are doubling the capacity, going to 2 times 1 megawatt stacks, plus 1 megawatt plus 2 megawatt EPU plus a transformer rectifier, it was more in the 1.4 to 1.6 million euro per megawatt, meaning a gain of 15 to 20%.
Well, you should come to an end, more or less.
Okay, and doubling again the capacity with a 4 times 1 megawatt stack and a 4 megawatt EPU and a transformer rectifier, you gain again 15 to 20% in terms of cost. So that is more or less in a pattern that we have seen already in solar panels or in batteries. By doubling the capacity, you are roughly gaining between 15 to 20% of the cost. And if we apply that to the next generation 16 megawatt EPU and 4 megawatt stacks, that allows our customers to get closer to the expected market price, which are around 700 to 800,000 euros per megawatt. And I will stop here. Thank you very much.
Thank you so much. Benoît Barrière from McPhy, thank you. Maybe you take a seat over here and could listen to the others. Take one of the three. Thank you so much. And we will go on with Tim Calver, Vice President Commercial at ITM Power. Welcome on stage, Tim. I join you.
Thank you. Morning, everybody. So pleased to be with you this morning. So, Vice President for Commercial at ITM Power. We're a PEM electrolyzer manufacturer. My responsibility is for everything customer related. So our business development and sales, execution of customer projects, and all of our operational and maintenance support for running plants also. So with the focus today on bringing down costs, I'm reminded of the poll that was taken in one of yesterday's sessions, where we heard clearly from customers that the most important metric is levelized cost of hydrogen. So I guess the lens I want to bring today is, obviously it's about stacks, but it's about the full integrated plant, CapEx and OpEx together. So it's great to be with two OEM colleagues today. It would have been great to have some EPC colleagues on the panel as well, I think, to cover the full CapEx of a total plant installation. Before I talk about cost levers, there are two, I think, important prerequisites that, as an industry, we mustn't skip. Benoît mentioned them also, and I'm sure there'll be some common messages across the OEMs on stage today. The first one is robust, high-volume, industrialized products, so the stack at the heart of the electrolyzer system. Without that manufactured at volume, operating reliably, we don't have the foundation for cost down across the industry. So in ITM's case, that's our 2 megawatt Trident system. That sits at the heart either of a containerized product, Neptune, or maybe most relevant for today, our Poseidon 20 megawatt core process module, which is the design that we will use for large-scale electrolyzer facilities. But again, fundamental is robust, industrial, high-volume products. The second prerequisite is doing this at the right scale with customers and EPC partners and gaining that critical delivery experience. So for us to talk credibly about safe design, execution, and operation of gigawatt-scale plants, as an industry, we have to have delivered multiple 20 to 100 megawatt plants to have that experience. So in our case, the examples we would give are, on the right-hand side, a 24 megawatt plant producing green hydrogen going into green ammonia with Yara in Norway. That plant is operational. And on the left-hand side, in build, is our contribution to the 200 megawatts being developed by RWE at Lingen. In both cases, we're working with our joint venture partner Linde on the EPC side. And what's really key here is this is customer, OEM, EPC working together through design, execution, and operation to really understand what it takes to scale up and drive down costs going forward. So then if I come back to stack and core balance of plant process module and what is important here. So again, it's already been mentioned, but fundamentally, efficiency and flexibility. So the biggest input to any business case is the energy cost. You lower the energy cost through the efficiency of the system and through the flexibility of the system to follow your renewable load in cases where that's important. So those will always be key design drivers. Then, so on the left-hand side, you see a picture of our 2 megawatt Trident stack and skid system. To bring down the cost of that, of course, we work on the underlying unit cost of materials. That's about reducing precious metal content, increasing levels of automation, procurement volume with our supply chain. There are also key drivers here that will impact the balance of plant costs. So current density, scale of the stack. As we develop those things, it reduces number of connections, it drives lower footprint, it reduces balance of plant costs. All of those things are a trade-off that, as an industry, we need to do around our stack design. But the point at the bottom here is fundamental. When it comes to stacks, this is really a volume game. We need volume commitment, and that allows us the certainty to make investments in our own manufacturing facility and also to drive our supply chain to make investments. Without volume commitment, cost reduction can't come. So I guess an important conversation with customers is, if you think you can wait for cost reduction, it won't come. We need to walk down that cost curve together with volume commitments that OEMs can invest against. And then finally, turning attention to the balance of plant. So for us, this is our Poseidon 20 megawatt core process module design. Again, just to reiterate, so 1/3 of CapEx is in the stack, 1/3 in this core balance of plant, and rule of thumb, 1/3 in the remaining balance of plant. Scale is definitely important here. So building bigger, of course, does have ability to drive down costs. But what we're fundamentally focused on is repeatability and standardization here. So we're using standard off-the-shelf components that we can replicate, and we are using skid-mounted, factory-tested units to minimize site work. Flexibly working with EPCs is really important. The customer wants us to do what we're best at, EPCs to do what they're best at, which will often mean procurement of the wider balance of plant system and detailed engineering. And in conclusion, a key focus on safety is really important here. So we are bringing together complex process plant across a number of different parties that we have to design, construct, and operate safely. So I think, with a key customer expectation, yes, to drive down costs, but we have to make sure that's done in a safe way throughout the industry. Thank you very much.
Thank you, Tim. join us at the discussion area. And our last speaker in this round is Dr. Andreas Lippert. He is Vice President and General Manager Electrolyzers by Accelera by Cummins. Welcome on stage.
Thank you. Good morning, ladies and gentlemen. It's great to be here and feel the energy in the room, and also just in the context of all the discussions of the past day and a half, and obviously to follow on from my colleagues in the industry who've each focused on different aspects. So I represent Accelera by Cummins. You may know Cummins as the diesel engine company. Accelera is our business unit that's focused exclusively on zero emissions technologies. That includes batteries, electrified powertrains, fuel cells, and electrolyzers, which I have the privilege to lead globally in the different facets, in the different regions of the world. So we are based in the US, in Canada, in Europe, in Belgium, and in Spain, and then also in China. So our history is really built on an acquisition of Hydrogenics that we made in 2019. Hydrogenics had both fuel cells and electrolyzers. We've really built out the fuel cell part as well as the electrolyzer part, and invested significantly. So this represents billions of dollars of investment that we've made, and to an earlier comment of leaning in to support those who are making these investments. This is not a small aspect for us. It is something very crucial in our evolution as a company. And maybe one context also is that one of our plants in Fridley, Minnesota, is actually being partly repurposed from building diesel and natural gas gensets to building electrolyzers. So that's the energy transition happening live in our own facilities. So our products, our manufacturing scale is beyond a gigawatt. Our products range from a small alkaline containerized product to a containerized 2.5 megawatt product to, as my colleague from ITM also showed, a larger 25 megawatt block, which really starts to incorporate some of those savings of the balance of plant, as well as stack improvements. So a next generation stack that actually increases the current density and requires less stacks, so immediately has a cost reduction built in. So I've taken a slightly different route, and maybe because I don't have such cool names like Neptune and Poseidon for our products, but maybe taking just a generic study to highlight a few things, maybe a little bit more quantitatively. So in this study from IRENA, you see that essentially the cost of the stack is less than half. Each of these numbers will of course depend on the exact size of the stack, the size of the plant. So these are indicative ranges, I would say. So indeed, the balance of plant is a very significant portion, and you could divide it into this balance of system, balance of plant. It's the rectifier and the power supply, it's the deionizing water solution, and it's the hydrogen purification process at the end for very high purity applications. And then if you look at the stack is really three key elements: the bipolar plates, the actual catalyst-coated membrane, and then the porous transport layers. And if you go even deeper into the catalyst-coated membrane, it's part membrane, it's part the precious group metals, and it's also the actual manufacturing. And this is where scale, automation, lean manufacturing, and really these learning curves that as an industry I think we're just at the beginning of seeing, and I can only echo, if we want lower costs at scale, then the market demand has to be there. But maybe also an important point is actually just looking at the sensitivity to operating costs. So this, again, from the IRENA study, you can look at the boundary conditions, but essentially the interesting part of this curve is just how strong the operating hour profile is on the actual cost of the hydrogen produced. And so in the vertical direction, it's a pretty linear scale. In the horizontal direction, it's a hyperbolic scale. And so in terms of the left-hand chart, which is focused more on the CapEx cost, you can see that above 3,000 hours, annual operating hours, the sensitivity to the CapEx of the electrolyzer really goes down. And below 2,000, it becomes quite critical. If you look on the right-hand chart, above 2,000 hours, it's really the renewable electricity price that drives the overall cost of hydrogen. And so people have used 2/3 as a number, but it's really, at the end of the day, the cost of hydrogen produced is not so much about the capex as it is about the operating profile and about the input cost, which is the renewable electricity. So that's also where some of the focus at the end needs to be. And again, all of these are just focused on the hydrogen production, not on the final transport and usage. And so just to close off, everything's a trade-off. And there are various trade-offs that you can make. Our first speaker, Benoît, talked about the trade-off between CapEx and OpEx. There are trade-offs between efficiency and durability. And all of these are embedded in the use case and the application of the customer. So there are various levers that one can pull, but at the end, it's really starting to tailor the actual machine to the use case. And with that, I'm getting the signal I need to sit down, so thank you very much.
Thank you, Andreas. 5 minutes is very short for such a complex topic, I think, but thank you for hurrying up. So now we have much more time for our discussion. I think that's important too. And maybe we will switch to the Slido and see which questions we should discuss. We will start with the first question from a component perspective. What are the most important topics in the stack to reduce the costs? Where could advancements in production technology have the biggest impact? Benoît, would you like to answer that question?
I can answer for alkaline technology,
Do
and
so.
I will let my colleagues...
Maybe it's a question for all of you.
Yeah. For alkaline technology, in terms of components, the most expensive is the cathode, where is made the hydrogen molecule out of H2O. And this cathode, there are several type of catalysts that are deposited on the cathode. There's a nickel sulfur technology. There's a microporous nickel technology called Rainy nickel, or a technology using platinum group metals. PGM, platinum group metals, are more efficient in terms of catalytic behavior and allows to decrease the voltage, so improving the energy efficiency of the stack. But the others are working well also, but at a lower cost. So it's a trade-off between cost and efficiency in between these three technologies. So decreasing, reducing the cost, we shall focus on the cathode chemistry, but also on the physics of the cell, the contacting elements, the flows, the bubbles, and also on the engineering challenges of the stack, how to hold the pressure. And McPhy has chosen to some frames in polymer versus metal that are that allow to keep the heat of the stack, so it's more suitable for intermittent electrical load. So there are different types of challenges to reduce the cost, both in terms of chemistry, physics, engineering,
but also different chances.
And different chances.
Thank you. Tim, would you add something?
Thank you. Yeah, of course. So from a PEM perspective, I'll maybe keep it at a high level because I don't have Benoît's technical depth, but we would think about the membrane and the coating to the membrane and then the electrode. That's where we've got the biggest material costs. The question asked about production technologies, maybe there's an interesting example from a membrane point of view. So we've recently gone from a sort of a spraying technology to a reel-to-reel screen printing technology. So, that optimizes the wastage in the process, also dramatically reduces cycle time, right? So you pull a number of cost levers by doing that. So there are a number of production technologies which can help with it. I guess I'd make the point though, fundamentally, reducing the level of precious metal will be a bigger cost driver than just production alone. So, and to Benoît's point, that is then a trade-off around performance, reliability, as well as production costs.
Yeah. Andreas, something to add?
Yeah, so I think maybe an additional element to reducing precious metal content is really, I think, again, stepping back as an industry, there are these product learning cycles. And a big part is not just the actual components, but the design integration. And so how do you design it to minimize the effort to produce it, to automate it, I think is also a very significant lever, and then ultimately the automation to produce it.
Thank you. Next question. I think we had it yesterday, but in a special way here. Which EL technology do you see for the future? PM, AEM? What do you think?
I mean,
We had that in a poll yesterday.
I will
remember.
answer, and I will let the others add their opinion. But what is driving the market are the large industrial applications to produce green hydrogen. So we are speaking about hundreds of megawatts. So I would say the technology that will be the future technology will be the technology that will be compatible with such large demand, and in terms of industrialization and performance, just to continue what was said previously, the automatization in terms of manufacturing will be key. So personally, I see a mix of alkaline and PEM, but I will let the others answer also.
I can change the order. I think we ask these questions if there's one answer, and I agree. There's not just one answer, because there's different use cases. And I think, quite honestly, the actual use cases are evolving. There will be a use case of base load. There'll also be a very strong use case of direct tie to renewable power. If we think about the experiments that China is doing at the hundreds of megawatt scale with predominantly alkaline electrolyzers. But the question is really, in combination, can we actually reduce the levelized cost of hydrogen as a system level instead of just focusing on just one technology? Obviously, I think PEM has a future, particularly with the efficiency and the operational flexibility, but there's certainly a case made for various applications.
Okay. You had something, or?
Maybe briefly. I mean, I guess we're all talking to customers the whole time, and this is one of the first choices they make. I think that choice today will be different to 5, 10, 15 years. I mean, when the audience was asked yesterday, they found PEM had a strong future. That's great, but I think we would all believe on the panel here, right, that a number of technologies are going to be needed to deliver at the scale that we need to.
Let's switch to another topic. What does your company do to increase the industry's focus on safety? Go ahead.
Please.
Sure. So I guess I made this point. I mean, I think this is where working together with EPC colleagues is fundamental. So, I mean, safety will be throughout all of our business, right? It's in our manufacturing operations. We take care in our supply chain. It's in our site operations that we do, but this maybe particularly talks about, process safety of large industrial plants. The process safety is an integrated design process with EPC companies, and so, really working carefully through the pre-feed and particularly the feed processes, and I think establishing strong relationships between OEMs and EPCs, so that we're not doing everything for the first time, right? That we learn each other's products and approaches, also culturally within the organization, so that we can really be clear how we manage safety holistically across the plant. So, I mean, we have there's a question later on that you might pick up around EPCs, right? We have a joint venture with Linde, and a big part of our work together there has been working on the safety of the plant in relation to the examples that I showed on the screen.
Yeah. Do you want to add something?
Agreed. The safety is really a culture question of process. So we are doing our ASOP studies, but also, I mean, looking at every incident, to find the root causes and fix them. So it's a question of culture that is now fully, within the industry, or at least within our company.
Andreas.
I just add that I think this is one of the key topics for us as an industry. There's a lot of questions I get from ordinary folks that just think hydrogen is a safety problem inherently. And the answer is it's a technical safety challenge, just like batteries, just like natural gas. And I think there's a big education effort that's needed. And we're focusing on training our people and everything from the facilities to the actual product.
Yeah. Okay. There's a special question, which type of gasket is used in AEL and PM?
I can answer for alkaline. We were using PTFE, but because of the PFAS directive, we are moving to, elastomers, so cheaper product. We don't need any fluoropolymers.
Okay.
Whoever asked the question, happy to get back.
Yeah.
I don't know the answer.
I don't know.
Okay.
I'm going to say the right
We
one.
had one
Yeah,
answer,
I mean,
that's okay. Yeah, did you already answer that question? What is the benefit for electrolyzer manufacturer to exclusively partner with an EPC company? This may exclude the manufacturer to participate in an EPCM project, which is common in gas business.
I started to, but I can answer it now. I mean, I guess there's a number of levels to that question. I mean, anyone that knows the history of ITM would know that we started out with an exclusive joint venture with Linde. Actually, that was very successful, I think, in both organizations working closely together to capture a significant market share of what was out there. We're working now on a non-exclusive basis, which I think is generally the way that's working across the industry. Customers are looking for a lot of flexibility in who they work with, how they work with. So, I mean, my point here would be having strong relationships between OEM and EPCs where we're not always forming a new partnership for a new project is really important. But I think the market probably needs us to have some flexibility to work with a number of different players so that we can ultimately be as flexible as possible for the customer.
Okay, thank you. How does recycling of the noble metals in PM electrolyzers plays a role in reducing the costs of electrolyzers? Question for you, Andreas or Benoît?
No, we are not in PEM, so I let them answer.
So I think that, that is pretty much a future topic, but it's certainly one that's important as you look 10 years out, and we start to really recycle stacks. And so that's what we plan with, which we talk with our suppliers. And obviously there's various methods that are being explored in how to best recycle them, in addition to the membrane itself, which is an important part of how you recycle this, is not just simply a thermal destruction of the membrane, but actually capturing that as well.
So you need partners also for that.
Absolutely, yeah.
The only thing I'd add to that, I think, is just in the manufacturing processes. So as Andreas said, I mean, certainly in replacement of stacks going forward, but minimizing waste and making sure you recycle within your manufacturing processes is key as well.
Okay, thanks. Chinese electrolyzer announces lower capex as European OEMs. What are you doing to compete? Provocant.
I can answer for alkaline. Indeed, it's a clear worry. If you look at the different components, the stack, I mean, the manufacturing part is quite low. It's more, the choice of materials and the know-how on assembling. For the process unit, there's more man-hour cost. So Europe is more threatened by Asia. And what are we doing for McPhy to compete is indeed to have the best technology, but also to continue partnerships with Asia. The partnership that we have signed with Larsen & Toubro, this Indian EPC company, to be able to manufacture our technology, our stacks and our process unit in Asia and being able to serve the world beyond Europe.
I mean, again, so customers will choose on levelized cost of hydrogen, not just capex, but I think we all recognize this as a threat, right? So what can we do? We can be the best we possibly can at improving our products and driving down our costs and accessing some of the same costs.
And maybe it's not the only key factor.
Yeah, I just say I think it's the total package. We talked about safety, hydrogen safety, the diligence with which you take care of that in your facilities, in your products, I think matters. And then I think, that's just global competition. I think, again, to me, the use cases are different. Most of the Chinese electrolyzer manufacturers are focused on alkaline. And I think, we need to build out the hydrogen infrastructure. So I think there will be many players and many answers.
Yeah. Our next question is going into the future. Does anybody of you have or may have an idea about that? market price for 1 megawatt core stack in 10 years? Don't think so, huh?
No, but my point would be right. I mean, we need also to separate costs and price.
Yeah.
So we all have a job to do to bring costs down. We also need to make money as an industry. And what happens to price will be market related. What happens to cost is relatively more in our control. I don't think any of us with any confidence could give a cost in 10 years, let alone a price.
Not the price, yeah. Okay. Next question. Which component in the electrolyzer plant is the most prone to failure or spare part requirement and OPEX intensive with the current state of the art for each of your technologies? Andreas, would you like to start?
Sure, and I'd say obviously the stack is the part that works the hardest in the plant, and you know, is doing all the work. So the stack is really the question on, you know, I talked about durability and efficiency. What are you designing for? What's actually the product life cycle that you want to achieve? And so I think that's, in my view, still evolving. There are many projections as to how this can last, but realistically, I don't think there's PEM electrolyzers that have done 80,000 hours. So I think everything is a projection at this point, and the question is just how we continue to optimize, and as we go in the scale-up and these product life cycles, what are we able to offer at each stage of the customer's life cycle?
Mm-hmm. Would you like to add something?
I mean, a couple of things. So I think, you know, the way we think about it, we think about sort of electrochemical degradation processes and then mechanical. And you know, and certainly, you know, we've done a lot of work, I guess, to learn from mechanical failures that we're seeing and feed that back into design and manufacturing processes. You know, we do a lot, I guess, at the sort of the lab and small scale testing to validate our view of durability of materials. I mean, the other point I would make here is, you know, we need to not forget about the balance of plant impact and I guess the importance of the right conditions there for stacks. We have seen a number of customers where we have had a failure and actually it's been rated to balance a plant. So there's a lot of work to do within the stacks, but again, part of that integration with EPCs actually is making sure that the balance of plant properly cares for the stack technology.
Mm-hmm.
And for the alkaline technology, that's the same. It's a stack which is working the most, and the degradation rate of the energy efficiency is key. For that, you need to have, obviously, some long runs and to get the feedback of running it under different loads, I mean, long enough. And as our customers sometimes are asking us for commitments on degradation rate, it's a little bit of a chicken and egg or catch-22 pattern, where, I mean, we are missing data to provide the right answers, but at the end, we will do it because we will get enough data and enough feedback on our electrolyzers.
Yeah, thank you. Next question is also focusing on the future, but maybe we can change the question a little bit. You were talking about efficiency before, and as I understood, there is space for improvement of efficiency.
There is space for improvement. Let's say, I mean, versus the current efficiency rates, I would see something like 10-20% improvement. You cannot go against thermodynamics. I mean, at one point you will reach, I mean, an asymptote. But clearly, I see 2030. In 2030, I think the efficiency rates at the beginning of life will be between 4 to 4.2 kilowatt hour per meter cube.
Mm-hmm.
Yes.
Mm-hmm. Which is the most critical component limiting the lifetime of your EL system? Do you guarantee a certain lifetime?
So this the second part, right? I guess we're in commercial territory, and we would all offer probably some kind of defect liability period as part of any commercial contract. Most critical. I mean, we've talked about a number of stack components, and you know, I think so what we've done is, I guess, continuously built back root cause analysis of any failures that we've had in the field back into our design and engineering processes. So I would say that, you know, there's a number of things that we're developing there, no one single particular failure mode.
Mm-hmm.
I'd agree. I'd say, you know, again, in the context of the stack and the BOP, it all depends on the design integration. And I think one critical element is to understand just how the balance of plant and how the stack really interact. And if you really do the systems engineering, what are you actually valuing more than the other? And that has an impact on which are the most critical components. If you value the stack above all else, you'll make your balance of plant give steady conditions. If you value operational flexibility, you'll require more. So I think it's really a question of where you want to optimize.
I think the next question is going in the same direction. How long is the product life cycle of the most common electrolyzer? Can you
So I guess this is talking about product life cycle rather than lifetime, right? Because I guess we've all talked about generations of stack development. I mean, I think I can only talk here for ITM, right? I mean, the stack generation we offer now, we will stand behind that for the duration of those plants. And actually what we've recently done is with one of our older generations of stacks, we've retrofitted more modern technology to it, and I think that's really important, right? You give customers access to technology improvements over time. So, I think for sure we will be developing further generations of stack, but I think what's really clear is that when a customer buys a product, they know that they will get full lifetime support for that and also access to technology improvements over time.
Yeah.
And
I think
sorry, please.
Andreas, go ahead.
I guess it's also an interesting question to the end user and the customer. How long should that be? And again, we're industrial equipment, so we're talking multiple decades.
What is demanded, huh?
And so to Tim's point, I think it's over multiple decades, maybe even a decade already, you're going to be able to offer your customers certain upgrades. And so I think whether it's electrolyzers or other big industrial equipment, I think you always have to think about how do you enhance the value generation for the customer throughout the product life cycle.
Benoît.
And for the alkaline technology, there are examples of more than 2 decades, electrolyzers that have been installed and have been running more than 2 decades. So it can be at least 20 years.
Yeah, okay. Well, our time is running, and I would like to invite you to add one special item, summing up this discussion about bringing down the costs and what does it take to build and operate electrolyzers from your own perspective. What are the main points? How could you sum up this discussion? What can you give to the audience as a last sentence? Andreas, would you like to start?
Sure. So I go back to a comment made in one of the earlier sessions today, which is be careful to over-optimize at the early stages of a marketplace, which is what we're at. So all of us sitting on stage here, Benoît showed the new factory, I could show you pictures of our new factory. We're all making very significant investments to lean forward, to drive manufacturing costs down, to scale up the supply chain. And I think we need this to function as a synergistic marketplace. We'll do our best to offer the technology and the products from the hydrogen production, but we need the rest of the ecosystem really to work. And part of what's standing behind us is even the suppliers. We talked about the smaller suppliers that are part of this whole supply chain that we're pulling along. So this is a scale-up exercise. There's lots of product learning cycles. And we're leaning in to make that happen.
So cooperation,
collaboration.
Yeah. Okay, thank you. Tim?
Sure. So I think maybe just the points that I summarised with at the beginning. So volume commitment. I mean, there has to be a volume commitment through customers, OEMs, and into our supply chain. Without that, we're simply not going to be able to justify the investments, gain the experience and drive down costs. And then again, I mean, I think maybe another 3 chairs for EPC colleagues here, right? I mean, ultimately it's about levelized cost of hydrogen, optimizing the overall plant, and we're all doing that with EPC partners. So I think making sure that you've got all of the right parties at the table to have that cost discussion.
So cooperation and communication. Thank you. Benoît?
And on my side, I will just repeat what I was saying at the beginning of my speech. I see 2 big drivers, innovation and industrial manufacturing. Innovation, there's a lot that happens in terms of new catalysts, new cathodes. I try to explain the importance of the cathode for alkaline electrolyzers, but also in the many different parts of the stack, and also in our collaboration with EPC companies for the EPUs. So we can really optimize all the chain of the different component of an electrolyzer. And second one is industrial production. McPhy is starting its gigafactory in an area that is famous for its automotive industry. We have a lot to learn from other industries in terms of manufacturing, robustness, first pass yield and things like that, to really, cut down the cost of electrolyzers through this massive industrialization.
Thank you so much. Thank you, Benoît, Tim, and Andreas.